everyone. In this lesson we're going to be talking about significant figures and how they rule. A lot of times significant figures are called sig figs. And we're going to be talking about sig figs rules, how they are measured, and the rules associated with them. A lot of you have heard about sig figs before, but some of you haven't. So some of this will be new for you no matter who you are. Alright. So first of all, let's talk about measuring with significant figures. We're going to measure with this ruler right here, and if we look at this ruler is actually, I know it says millimeters here, but that means that each little mark is a millimeter. Alright, so this full thing is a centimeter. So what we want to look at every time we measure, we want to look at what the little marks mean. What do they represent, or what is the interval of those graduations or marks? On a ruler, there's just marks that are made between numbers. On a graduate cylinder, they'd be graduations. But what do those marks mean? So in this case, if this is a full centimeter, each one of those marks would be 1/10 of a centimeter. So my interval is 0.1 centimeter. So that's where a measurement is for sure. We can know that it's to a certain point of one of those marks. Okay? Now let's say that we are trying to measure some of these arrows. I'll do this last one first. If we're trying to measure this arrow, if I look at that, it's between 6.1, 6.2, and from what I can see, it's between 6.2 and 6.3. When we measure with significant figures, we need to imagine that there are 10 more marks in between. There are actually 9, but we need to imagine that there's more graduations in between those two lines, and we need to estimate one more digit. So if our interval is 0.1 centimeters, we are going to estimate every time we measure to 0.01 centimeters, plus or minus. That is going to be our uncertainty with our measurement. So if I look at that, I think it's closer to the 6.3 than the 6.2, and if I had to estimate that, I would say it's 6.28 approximately. It's closer to the 6.3, plus or minus 0.01 centimeters. And that's how we're going to report any measurements that we take with a ruler or graduate cylinder. We're going to look at what we're using, and then plus or minus a certain amount. Alright? So, we take a look at this one, the mark that we made here. I'm going to do this one with you also. So this one I would say is this is the 2.5 right here, 2.6, 2.7, 2.8, 2.9. So I'd say it's between a 2.8 and a 2.9. Oops. And it looks really, really close to the 2.8. So if I had to estimate that one, I'd say it's 2.81 plus or minus 0.01 centimeters. Alright, what I'd like you to do is try this one, just the end of this arrow right here. I would like you to estimate what you think that measurement should be measured at. What do you think the measurement should be here? Go ahead and press pause and write that down on your sheet. And press play when you think you have it figured out. Alright, welcome back. As I look at that, it is between this is a 0.6 and this is a 0.7 mark. So it's between 0.6 and 0.7. So in this case, to me it looks like it's right in the middle of 0.6 and 0.7. If that's the case, it would be 0.65 plus or minus 0.01 centimeters. That's our uncertainty. Because there are some other people that might look at that and say that looks like 0.64, and someone else might say it looks like 0.66. But that is our uncertainty, plus or minus 0.01 centimeters. It's okay for the person next to you to have a different measurement than you. I always get the question, well, what if it's right on the mark? What if it's right on the gnat's eyebrow? It's right there. Well, you still need to go 2 numbers past the decimal, but you say it's right there by saying it's 10.00 centimeters. All right, let's try another one. If we look at a graduated cylinder, the graduated cylinder, we'll have put two graduated cylinders up here. The graduated cylinder, we have two different graduated cylinders here. If you notice, the graduations here are 51, 52, 53, 54. It's full number milliliters. So my interval here is 1 milliliter. That means that my measurement is going to go to the 0.1 milliliter, plus or minus 0.1 milliliter will be my final measurement. So if I look at this one, I might look at the bottom of the meniscus, so right about here. It's between the 52 and 53. So if I had to estimate this, I'd say it's 52 point, it looks like it's really close to the 53, so 52.8 milliliters, plus or minus 0.1 milliliter. All right, so I want you to look at this one, and I want you to first of all determine what the interval is, what does each line represent, and then what the value should be of that measurement. Go ahead and press pause, and then press play again to see what I think the answer should be. All right, welcome back. As I look at this, this is 4.1, 4.2, 4.3, 4.4, 4.5. So each one of these lines is 0.1 of a milliliter. So that means my measurement is going to be one spot past that, or 0.01 plus or minus 0.01 milliliter that I will measure it to be. So when I look at this measurement, I'm going to say it looks like it's between 4.5 and 4.6. And I would say it's about halfway there because I need to look at the bottom of the meniscus, the bottom of the curve. So I'd say it's 4.55 plus or minus 0.01 milliliters. So that is how we measure. You need to take a look at the device you're using because different devices have different amounts of marks on them. And the interval is going to be different depending on what it is. Some beakers have a mark for every 100 milliliters or even more depending on how big that beaker is. So in that case, if a mark was for every 100 milliliters, you could only estimate to a tenth of that or to the tens for that beaker. So it totally depends on the device that you are measuring with every time that you measure. So you need to look at that device, look at what your interval is, and then you can go a tenth of that every single time. All right, I want to show you one more measurement. As we look at this thermometer, we're going to take a look at what these marks mean. All right, so this is 100, and this would be then 110. Even though there's not a 1 in front of it, it's going up in temperature on this thermometer. So this mark would be 103, and this mark would be 104. So that tells me my interval is 1 degrees Fahrenheit. Each line is representing a degree. So that means that I can go to 0.1 degree Fahrenheit, plus or minus 0.1 degree. So that's what my final answer is going to be. As I look at this, I see that it's closer to 103. So I'd say it's 103.3 plus or minus 0.1 degree Fahrenheit. So that's the last one that I'm going to show you on this lesson for measuring. All right, now I want to talk about some of the rules associated. So you've made a measurement or you're given a measurement and you need to try to figure out how many significant figures there are. And you may say, well, why? Well, once we start calculating, you need to know what digits are significant and which ones aren't. And where it becomes important, especially, is when you have zeros involved. So as I look at this definition, and this should make sense from our measurements, significant figures are all that known with certainty plus the first one that's uncertain, because when we had a full interval, we always went to tenth of that, or one more spot beyond that interval, and that was our significant figure measurement for the device that we're using. So what are the rules for counting significant figures? Well, if you have a measurement, say, of 124 meters, there's no zeros. So the major issue is zeros. If there's no zeros, every digit there is significant. So that means here we'd have 3 significant figures. All right. This one on the bottom, we would say that zeros sandwiched between non-zero digits are significant. Okay, that's another rule. There are a few rules in your book, and you don't have to memorize them all because I'm going to show you a way to do it a little bit easier. But zeros sandwiched are significant. So here, since these are not zeros, those are all significant, but then these zeros are sandwiched in between, so that makes them significant. It's the zeros on the very left side of a measurement or the very right that are tough to decide. But these zeros are significant, so that would give me a total of 5 significant figures for this measurement. 5 significant figures. Okay? Moving on. Now there's lots of other rules that you will see in your book. But I can sum all of them up with the Atlantic Pacific rule. First of all, you need to know that this is a map of the United States and where USA. Okay? And that on the left of the United States is the Pacific Ocean, if you're looking at a map, and on the right of the United States is the Atlantic Ocean. That's very important. If you don't know where the Atlantic and Pacific Ocean are compared to the United States, this rule is not all that helpful. So you need to know that. Next, we're going to look at the first statement in the rule. If a decimal point is present, ignore the zeros on the Pacific side. Present Pacific. Present Pacific. So that's here. Present is on the left. If the decimal point is present, so I see a decimal point, it's right there, it's present, I'm going to ignore these zeros on the Pacific side or on the left side. That doesn't mean they're not significant. All it means is that, or it does mean they're not significant. Doesn't mean they're not there. They're placeholders. It just doesn't mean that they're not significant. The only significant figures in this measurement are those 4. All right. In this measurement, there's a decimal point present, but there's no zeros on the Pacific side of the measurement. There's nothing over here. So that means that every digit in this measurement is considered significant. So there'd be 6 significant figures in that measurement. All right. What about the Atlantic side? If the decimal point is absent, ignore them on the Atlantic side. So, as we look at these 2 examples, the Atlantic side is on the right over here. This is the Atlantic is over on the right-hand side. So I'm going to ignore these zeros on the right-hand side. Act like they're not there. Well, they're there. They're placeholders, but they're not significant. So the only significant digit here is this 1. So there's 1 significant figure in that measurement of 10,000. What about here? This is the Atlantic side. So I come here, and it's this one that is not significant. These other 3 numbers, the 2, 0, and the 1 and the 3, are all significant figures. This 0 is not considered significant. All right. So the last thing I'll talk about with significant figures is what you do when you calculate with significant figures. So that's the reason why we want to figure out which numbers are significant in a measurement. So the first thing we talked about was how to measure with the correct way with different devices. But a lot of times, after doing those measurements, you need to use those measurements in some sort of calculation. So how do you use those measurements in a calculation? So first of all, we're going to talk about how you add and subtract using significant figures. And we'll be practicing this and using this all semester. After that, we'll talk about multiplying and dividing, and that will be the end of this lesson. So, what's the rule for adding and subtracting? In your answer, you can only use the number of significant figures after the decimal that there isn't a number that was added or subtracted with the least sig figs after the decimal, or the very left placeholder, and I'll show you what I mean by that here in a bit. So here's an example. If you put in your calculator 213.2 plus 411.110, your calculator would spit this out. And it would say, well, this is the answer. Okay? But here, our device that we used, our ruler that was used, can only go 1 number past the decimal. And here, the ruler was a little bit more precise and could go 3 numbers past the decimal. A lot of times we talk about the measurements can only be as good as the final measurement, or calculation can only be as good as the worst measurement originally. So here's one number past, here's three numbers past. So my final answer can only go one number past. Even though my calculator gave me more numbers, my correct answer to the correct number of significant figures is only one number past the decimal. Okay? Here's another problem. What if you're subtracting? It's the same rule. Adding and subtracting is always past the decimal that you're looking. Well, we don't have anything past the decimal here. There's nothing past the decimal. Here, there's one significant figure past the decimal. So out of the two, I can only use the least amount, so I can't use any past the decimal. Well, if I do this math, I get 38.6 meters from my calculator. So my calculator gives me this, yes, but based on the measurements, the correct answer cannot go any numbers past the decimal, and we round that up to 39 meters. So in adding and subtracting, you're always looking at the placeholder, the left placeholder. I always get the question, well, what about a number like 120? And then you're adding that to 122. All right, something like, oh, let's just say 0.4. Okay, if I put that in my calculator, I'm going to get 242.4. But this was a measurement in meters. This was a measurement in meters. When I see something like that, that was 120 for the measurement, that means that the measuring device was something like this. It had a 100-meter mark, and it had a 200-meter mark. And then the measurement was in here somewhere. And the person that measured it, best they could do is 120 meters. That's where a measurement like that would come from. Well, that's not a very accurate measurement. So the final answer can't be that accurate. So if we add those two together, the best I can do is to that placeholder, to the tens. So the answer that you would give, you would round to that place, and it would be 240 meters would be the final answer given, based on that measurement not being very good. That's the issue with it. So when that one measurement's not very good, the final addition can't be very good. I know you're wondering, what about multiplying and dividing? What's the difference? Okay? In multiplying and dividing, it is the least number of significant figures, not after the decimal, not which placeholder, but total significant figures. Total significant figures. So if we look at these, least number total significant figures. So a number like this has 4 significant figures. A number like this has 3. If I put that in my calculator, take a tiny bit of time here, we'll put that in my calculator. 41.46 times 1.19. I'm going to get 25.5374. 25.5374. All right. Now, how do I round that? Because I have 4 significant figures and 3 significant figures. I can only use the least amount. I can only use 3 significant figures in my answer. So here's the first one, here's the second one, here's the third one. So I'm going to round that number, that 5 needs to get rounded or kept the same. If the number behind it was a 5 or higher, I would say 25.6. Since the number behind it is a 3, I'm going to say 25.5 centimeters squared would be my final correct answer. What about dividing? Well, dividing is the same exact rule. So I look at a number like this, number like that, which has 4 significant figures in it. And I look at like a number like this, which has 2 significant figures in it. I put it in my calculator and I get this long drawn-out answer. And the calculator is right. If it was just numbers, that would be the correct answer. But we need to worry about the fact that these were not measured the same way with the same amount of precision. So my final answer can only have the least amount of the 4 or the 2, and of course that's 2. So the answer that you would give, as far as the density of this object that you measured, would be 2.0 grams per milliliter. And that is as many you can go with that. So with multiplying and dividing, it is the number past the decimal. With adding and subtracting, it is, with adding and subtracting, it's the number past the decimal. Multiplying and dividing, it is the total number of sig figs. So you're always going the least past the decimals, adding and subtracting, and the least total when you're multiplying and dividing. That's all I have about significant figures for now. Please bring your completed note sheet to class. That's right, 2 smiling faces.